Okay, so today we will see the one of the another topic of the AZ-305, that is designing Azure storage solutions and data platform. Okay,
Mm.
so before we begin the today's sessions, let's quickly recap what we learned in our previous sessions. Okay, so in our previous session we focused on the Azure security, governance, enterprise access control. Okay, and we covered the conditional access, zero trust architectures, risk based access control, Microsoft intra identity protections, privilege identity management, that is PIM, Azure policy and policy initiative, and resource logs and enterprise governance design. So most importantly, we learned what the modern cloud architecture is not just about deploying the resources. It is about ensuring the security, compliance, governance, um, operations control. Okay, across the entire Azure environment. Now we move to another major AZ-305 domain, which is design data storage solutions. So as Azure architecture, almost every solutions we design involves the data. Applications may fail, servers may be replaced, container may be recreated, but the data is often the most valuable assets and organizations own. So that's why the storage architecture decisions are among the most important decision an Azure solution architect makes. Okay, so why today topic matter? So imagine the following organizations. So let's suppose there is a global bank and which stores the customer accounts, transactions, loan documentations. Okay, and also and another organization like healthcare provider which store the patient's records, medicals
Mm.
images, compliance data, and there is also another company which is e-commerce company which is store the product images, customer orders, or payment informations. Okay, and if I go with another example like a streaming platform just like Netflix, so it is stored videos, metadata, analytics. So all these scenarios data must be available, durable, secure, scalable, okay, recoverable, or cost efficiency. So poor storage architectures can lead to data loss, downtime, compliance violations, excessive cost, and poor application performance. So as
Okay.
Azure architecture, our role is to design storage solutions that balance the ability, durability, performance, security, and cost. Okay, so
Yeah.
while meeting the business requirement from an AZ-305 perspective, which is Azure architect perspective, storage architecture is one of the most heavily tested domains. Okay, and from a real world perspective, it is one of the most important responsibility of the cloud architect. Okay,
Okay.
so what are the learning objectives here? Like by the end of this sessions, we will able to see how to understand the Azure storage architecture, design the storage solutions for the enterprise workload. We'll uh, look how to understand the Azure storage account, evaluate the storage service options, and also design the secure storage architecture and understand the durability and availability requirement. Okay, and also apply the storage design principles to the real world scenario, and also like do some we will go some with the three AZ-305 storage related exam scenario. Okay, so now we have to understand why storage is critical. Okay, let's begin
I
with the
can't see it. It's small. I can't see.
you can't see.
Yeah, it's small.
So now what we understand why the storage is critical. Let's begin with the foundation of Azure storage architecture. Okay, so Azure storage accounts, like in every storage service start here. Okay, so one of the most common mistakes Azure beginners make is assuming the blob storage, file storage, queue storage, or table storage are completely separate services. Okay, and in reality all these services are delivered through a storage account. Okay, like think of a storage account as a storage management boundary of Azure storage services. So without a storage account you cannot create a blob container, Azure Files, Q tables, okay, and disk. Okay, so the storage account act as a parent source that hosts host these services. Okay, these are services hosted by the storage accounts. Okay, so now if we go deeper, what is an Azure storage account? So an Azure storage account is a globally, okay, unique Azure resource, okay, that provide a namespace for storing the data, and it serves as a container for Azure storage service. So within a single storage account, you can host the blob storage and object storage. Okay, and what in Azure files? So in Azure files, you manage the files here, and what's in queue storage? So you manage the message storage. What in table storage? So there will be no SQL key value storage. And what in the data lake storage Gen 2? So analytics optimize storage. Okay. So think like of this. Let me. Okay. So think like this. There is storage account. Okay. And under this, okay, under this, there will be your blob storage. There will be your Azure files. There will be your queue storage. There will be your table storage, and there will be data lake Gen 2. Okay, storage. So these are, so the storage account become the logical management layers for all the storage services. Okay, so another question arises: why do we need storage account? Okay, why do we need a storage account? So answer will be a storage account provide a centralized control for security, which access the management, networking, like private endpoints, firewall rules, replications, which regulate the data durability, monitoring, which is matrices diagnosis, cost management, which is billing and lifecycle management. Okay, so without the storage account, managing the enterprise scale storage environment would become extremely difficult. Okay, so let's take the uh, some real world scenario. So imagine a global retail company, okay, in which the organization operates the mobile applications, web applications, analytics performs, and backup solutions. And what is the requirement?
Yeah.
So requirement is a product image which is stored in the blob storage, shared department files which is stored in the Azure files, ordering the processing message which is stored in the queue storage, and customer metadata which is stored in the table storage. So instead of managing the separate storage platform, the company organized the service through the storage accounts, and this simplifies the governance, monitoring, security, compliance. Okay, so now let's take the storage account types. Like how many storage have a types. So our tech must understand the storage account types because our AZ-305 frequently takes this topic. Okay, so there is, if you see, there is two two type of accounts, storage accounts. First one is general purpose, which is V2 or GP V2, like which we also
Yeah.
call the
And the
standard one.
premium.
Okay, so mostly common use, like it supports the blob storage, file storage, queue storage, table storage, data lakes, Gen 2, life cycle management, and latest features. Okay,
Yeah.
and if you see general purpose V2 account support the latest Azure storage features, and all services are cost effective per GB, support all the XSTS, recommend for the most scenarios, mag- magnetic or SSD backing. Okay, and what about the premium storage account? So premium storage account designed for low latency, high
Okay.
IOPS, performance sensitivity workload. Okay, like example, database, enterprise applications, high performance file share. So if you see the performance, premium performance is the high performance accounts for low latency scenario using the solid state drive, which is SSD, which is blobs for high transaction rates, page blobs for unmanaged disks, file share high perform SMB, and predictable high IOPS. Okay, so let me give you the simple architecture diagram for the storage account. So what will be our architecture diagram for the storage account? Okay, so it will be first your blob, okay, then file, then
Then key storage.
queue, then
Storage.
table, then
Then data lake.
data lake. Okay, so these are your simple architecture diagram for a storage account. So let's take the component example. Okay, so a storage account is like management boundaries and host storage services, and blob storage store the unstructured data. Example: emails, video, document. What's come under the Azure files? So it's manage the NFS file shares. What's come under the queue storage? So message based communications. And what's come under this table storage? So like and NoSQL storage. And what's come under the data lake Gen 2? So big data analytics workload. So what will be the step by step work request workflow? So the step one will be application connect the storage account. Step two will be authentications occur. Step three authorization validated. Step four blob container selected. Step five step five file uploaded, and step six replications occurs automatically. And last, the step seven will be monitoring record activity. Okay, and what's under the internal processing? So behind the scenes, Azure perform the authentication, authorization, inscription, replications, metadata management, durability operations. So becoming the so before confirming the successful storage. Okay, and what will be your security consideration? So architect should implement the private endpoints, storage, firewall, RBAC, encryptions, managed identity, and SaaS control. So storage
Okay.
security is one of the most important architecture responsibility. Okay, and what's
Yeah.
come under the governance considerations? Okay, so organizations should standardize like naming convention, tagging standard, life cycle policy, backup requirement. Okay, so storage governance reduce the operational complexity. Okay, and what's come under the scalability considerations? So Azure storage can scale to petabyte of the data, millions, billions of the objects, and massive throughput requirements, which architects should design for the future growth. And what will become under the high availability consideration? So storage architecture should support the zone failure, data center failure, regional outage. So this is achieved through the replication strategy, which we will study in our next part. Okay, or next topic. And what's come under the disaster recovery considerations? So architecture must define the recovery objective, replications mode, backup strategy, geo redundancy requirements, and storage DR planning is critical. Okay, and what's come under the cost optimization considerations? So architecture should evaluate the access pattern. Okay, and storage tiers, retention period. Okay, and replications requirement. Okay, so incorrect storage design can significantly increase the Azure cost. Okay, So and what's come under the monitoring concentration? So in monitor, which monitor the capacities, uses, transaction, latency, ability, replication health. Okay, so storage monitoring helps to identify the both performance and the cost issues. Okay, and what will be the common mistakes we do? So creating the too many storage account unnecessarily. Okay,
Okay.
ignoring the security control.
Security
Okay,
control, yeah.
yeah, no life cycle policies. Okay, wrong storage account types, overusing the premium storage, no replication
Mm.
planning, and poor naming standard. And what is the
Yeah.
best practices? So let me write in the chat so you have a note. So best practices. Okay, secure the storage by default. Okay,
Okay. Mm.
then implement the implement the private endpoints. Okay, then
Mm.
use RBAC, then plan replication.
Mm.
Okay, carefully, then
Yeah.
monitor continuously, then last, design for the scalability. Okay,
Okay. Mm.
so these are the best practices. Okay, so now
Mm.
let's take the exam perspective scenario. So you should expect the question evolving around the storage account types, GPv2 versus premium storage services, security architectures, and storage design decisions. So, and what are the common exam scenarios? So, suppose the organizations required the support for the blob storage, Azure Files, lifecycle management, and the future storage features. So correct architecture recommendation will be general purpose v2, GPv2, because it support the broadest range of the capabilities. Okay, now let's move to the next topic. Okay, so in our previous topic we learned what the storage account is foundation of the Azure storage services. Now let's address one of the most important questions every Azure architect must answer. What happen if the disk fail? Okay, what happen if the ability zone fails? Okay, what happen
Mm.
if the entire Azure regions goes offline? So
Yeah.
if
Mm.
your organization stores customer record, financial transactions, healthcare data, productions backup, okay, so data loss is unacceptable. This is why the Azure provide the multiple replication and redundancy options. So choosing the correct redundancy model is one of the most important and frequently tested topic in our AZ-305, and one of the most
Mm.
important real world architecture decision. Okay, so imagine a global bank storing the transactions record. Okay, and every second deposit occurs, withdrawals occurs, payment are processed, balance are updated. So if storage exists on only one set of disks, which is uh, so it will be storage failure, data loss, or business impact. Okay,
Mm.
so this is unacceptable. So enterprise architecture requires the durability, ability, fault tolerance, or disaster recovery. So Azure storage redundancy is designed to achieve these goals. Okay, and what is the storage redundancy? So storage redundancy refers to Azure automatically, okay, maintaining the multiple copies of the data. Okay, and these copies protect against the disk failure, server failures, rack failures, data center failures, ability zone failures, and regional disasters. And the more protection required, the more copies Azure maintain. So why do we need the redundancy? So without redundancy, right here, why do we need
Redundancy.
redundancy, because single disk single disk failure, then application outage, then potential data loss. Okay, so that's why we need redundancy. Okay, and without redundancy, and with redundancy, disk failure, secondary copies available, and service continues. Okay,
Redundancy, yeah? Why do we need redundancy is the question.
sorry.
Why do we need redundancy? So, single disk failure.
Okay, so why we need the redundancy? Okay, first take the technical definitions. Okay, let's let's listen carefully and understand. Azure redundancy is a design principle that involves the replicating the data, applications, and resource across the multiple locations like your data center, zone, okay, uh, region to ensure the high availability, fault tolerance, and disaster recovery in case of failure. Okay, now let's take a simple explanation. Okay, so Azure redundancy means keeping the copies of your data or system in different places. So if one place fails, other can still keep things running. Okay, just simple line. Don't keep your all your eggs in one basket. Okay, got it. And why?
Yeah.
Okay, so why we really we need Azure redundancy? It's to avoid the downtime. Okay, so if one server data center goes down, another will be take over it. Okay,
Take over, yeah.
yeah. Suppose your website is running in one data center. Okay, and if that data center crashes, website goes down. But if you have redundancy, the another data center already has a copy. Website continues working.
Mhm.
Okay, so that's why we need redundancy. Okay, so if I told you in one liner, okay, so Azure redundancy is equal to your backup plus safety, okay, plus always available systems. Okay, so this is one liner for Azure redundancy. Azure redundancy is equal to backup plus safety plus always available system. Okay, so what are advantage of the redundancy? So it has a lowest cost, simple, high durability against the hardware failure. And what are the limitations? So no zone protections, no regional protections, data center outage may impact availability. And what is the use case? So deployment environment, non-critical workload, and temporary data. Okay, so these are the examples. So and these example is come from LRS. Okay, local redundant storage. Basically, Azure provides five primary redundancy models. Okay, the first one is LRS, which stores the free copy within the single data center. Okay, let me write here. So LRS always stores free copies. Okay, copy one, copy two, copy three. Okay, and what is its limitation? So no zone protections, no regional protections, and data center outage may impact availability. Okay, and the second will be your ZRS. Okay, this is your second will be your ZRS. Okay, So GIS store the data across the multiple ability zones, like within in the same region. Okay,
Mm.
like its architecture say ZRS architecture says zone 1 have copy 1. Okay, zone 2 have copy 2, and zone 3 have copy 3. Well, these are all same copy, but zone 1 has a one
Okay.
copy, zone 2 has a one copy, zone 3 has a one copy. Okay, so
Okay.
what is the advantage? So it survives zone failure, high availability, strong resiliency. Okay, and what is the limitations? No across region protections. Okay, and what is the use case of the ZRS? So productions application, business critical workload, high availability solutions. Okay, and third one is your GRS, which is geo redundant. Okay,
Yeah.
and GRS maintain the three copies in the primary regions plus free copy in the secondary pair region. So what is its architectures? So primary regions has three copy, replication, and secondary region has a three copy. Okay,
Mhm.
so let me write here. GRS has primary region as three copies, then its replication to secondary region, which has
Okay.
also three copies. Okay,
Yeah.
okay. So what is the advantage of GRS? So it is a regional disaster protection, excellent durability. Okay, and what is the limitation of GRS? So limitation will be your secondary regions not readable by default, and its cost you higher. Okay, and what is the use case? So business critical system, disaster recovery workload. Okay, and the fourth one is your is GZRS, zone redundant. Okay, so it is a basically so it is a basically uh secondary region becomes readable. Okay, same as a GRS, and architecture will be your primary regions have a read plus write, then replications, then secondary region, and which has a read access. Okay, an advantage,
Okay.
it has a read access during outage, improve business continuity, better reporting scenarios, and limitation will be more expensive. Okay, and what are the use cases? So it's reporting the workload, global applications, read heavy scenario. Okay, so these are the GZRS. Okay,
Okay.
so what will be the architecture decision framework? So Azure architecture should never choose the replication based solely on the maximum protections. Instead, evaluate the
Okay.
business critically. How important is the
Okay.
data? Okay. Also look for the data
Okay.
requirement, like what downtime is acceptable. Okay. Also
Oh.
look for the
Yep.
regulatory requirement, like are backup required cross religions. Okay. Also look
Yeah.
for the budgets. What cost constraint exists? Okay. Also look for the performance requirement. Is the secondary region access required or not? Okay. So
Hmm.
these are the decision framework which are
Okay.
they
That's good
taken
to
by the
know.
architecture. Okay, yeah.
Yeah.
And what will the disaster recovery perspective? So disaster recovery recovery focused on recovering the after release regional disaster, and which is the best choice is GRS, RAGRS, or GZRS. Okay, and what will the
Yeah.
architecture diagram for the regional digester scenario? Let me write here. Architecture diagram for regional disaster scenario
Okay.
will be: first, primary region, then
Okay.
goes to regional outage, then failover, then secondary region, then application restored. Okay,
Okay.
and what is the failure scenario analysis? So let's evaluate these several failure events like disk failure, okay, server failure, ability zone failure, regional failure. Okay, and what is the security concentration considerations? So replication does not replace the security. Okay, architect must still implement the encryptions, RBAC, private endpoint, network security monitoring. Okay, and governance considerations will be: your organizations should standardize the replication selections, recovery objectives, storage classifications. Like the different data category may be require different redundancy model. Okay, and what is the scalability consideration? So all redundancy models support the enterprise scale workload. Okay, and architecture should focus on the business requirement and recovery requirements rather than the scalability limitations. And what will be the cost optimization consideration? So it will be the general cost ranking will be, let me write here, general cost ranking look like: first it is LRS, then it is ZRS, third will be your GRS, fourth will be your RAGRS, and fifth will be your GZRS. Okay, and higher diligence generally means the higher cost. Okay, architecture must balance the cost, ability, recovery. Okay, and monitoring consideration will be a replication status, storage ability, failover readiness, regional health, and capacity growth. Okay, so monitoring validates redundancy effectively. Okay, okay. So now we are going to see the designing blob storage, access tiers, lifecycle management, and enterprise data storage architecture. Okay, so in our previous topic, we learned how the storage protects the data using LRS, GRS, ZRS, uh, GZRS. Okay, now we understand how the Azure ensure the durability and ability. Okay, and the next questions on the Azure attack must be answered: what type of the data we are storing, because not all the data behave the same way. For example, product image, video, backups, applications log, IoT sensor data, and documents. Okay, and also the machine learning data sets. So all have a different access pattern. So this is where the Azure Blob storage becomes one of the most important storage service in the Azure. Okay, so when organizations move to the cloud, one of the first storage service they adopt is blob storage. Why? Because most enterprise data is unstructured data. Okay, like PDF, image, video, audio files, backup files, applications log, JSON files, or CSV files. So traditional relations databases are not optimized for storing these large objects. Okay, then blob storage is. So today the Azure blob storage is the extra byte of the data, billions of the objects, massive enterprise archives, and also the global content delivery platform. So an Azure architect understanding the blob storage is the essential, because it is used in data lake, AI ML solutions, backup, disaster recovery, media platform, enterprise applications. Okay, so what is blob storage? So blob storage stand for binary large object. So Azure Blob Storage is the Microsoft object storage service designed for the massive scalability, high durability, cost effective storage. Okay, so it store the data as objects rather than the file on the traditional file system. So think of this blob storage like, let me like right here. So blob storage is like storage account having container, and a container having blob 1, 2, 3, 4, etc. Okay, so these are a simple flow of the blob storage. And why we need the blob storage? So imagine a streaming company. They store the movies, thumbnails, metadata, subtitles. So data size is petabytes. Traditional file servers become expensive, difficult to scale, complex to manage. So blob storage provide the massive scalability, global availability, high durability, cost optimizations. Okay, so these are the example of the blob storage. Now we will see the designing Azure Files and Azure Data Lake storage gen and enterprise storage architects decision. Okay, so in our previous topic, we explored the Azure Blob storage and learned how the architecture design object storage solution using the blob container, blob types, access tiers, lifecycle management. So, however, not always applications are designed to use the object storage. So many enterprises still depend upon the shared file servers, SMBCS, departments, drives, legacy applications, analytics platforms, big data workloads. So as a Azure architect, we must know when the blob storage is right choice and when another storage service is more appropriate. So this lead us to Azure file. Okay,
Okay.
this lead us to Azure files and Azure data data lakes storage Gen 2. Okay. So imagine okay. So imagine a company moving to the Azure. So they currently operating the file server one, finance share, HR share, engineering shares. Okay. So thousands of the users access these shares daily. So you expect the drives mapping, file explorer access, share folder, existing SMB application. So rewriting every application to use the blob storage API is unrealistic. So our tech needs to need a cloud native file sharing solution. So this is where Azure file becomes most important. Okay, and at the same time, the data analytics
Okay.
teams may be storing the petabyte of the telemetry, machine learning data sets, data warehouse exports, and IoT stream. So these workload requires a completely different architecture, and this is where the Azure Data Lake Storage Gen 2 becomes critical. So what is a Azure Files? So
Mm.
Azure File is a fully managed file shared service. It provides SMB protocol supports, NFC supports, shared file access, cloud hosted files, and think of the Azure File as enterprise file server as a service without managing the file window file servers. Okay, and why do we need Azure files? So consider a traditional environments like user have a window file servers and shared folder. So what is challenges? Server maintenance, patching, hardware upgrades, capacity planning, backup managements. Azure file eliminates these operational burden. Okay, so so what what are the difference between the Azure files versus blob storage versus data lake Gen 2? Okay, so one of the most important or common AZ-305 comparison objects. So suppose there is features. Okay, so in SMB support features. So in Azure file, it is supported. Blobs are not supported. Okay, Gen 2 not supported. File share access, it's supported in Azure file but not supported in Blob storage and Gen 2. For object storage, it is not supported on the Azure file but supported on the Blob storage and the Gen 2. Analytics optimize, it is not supported on the Azure file, not supported on the Blob storage but supported on the Gen 2. Data lake workload, which is not supported on the Azure files, not supported on the Blob storage but supported on the Gen 2. And what for the legacy application support features? So it's supported on the Azure files, not supported on the Blob storage and not supported on the Zen 2. So ITech decision, what will be the architecture decision framework? So choose Azure file when shared drives require assembly needed, legacy application exist. When to choose the Blob storage? When you have structured data, storage, object storage,
Yeah.
media storage, or
Yeah.
general purpose. And when to choose data
Yeah.
lake Gen 2? When you have a big data analytics, machine learning,
Specific.
data engineering. Okay. So, and what will the scalability consideration? So Azure file support enterprise file workload. Blob storage support billions of the objects. Data lake Gen 2 supports the petabyte scale analytics. Okay. So there is a high availability consideration. So all services can leverage the ZRS, GRS, or GZRS depending upon the business requirement. And what will the common mistakes? So using the file storage for the analytics workload, using the blob storage when the SMB access is required, no lifecycle management, poor data organizations, ignoring the access patterns, no governance standard. And what will your best practices? So choose the storage based on the workload requirement. Use Azure files for SMB scenario. Use blob storage for object storage. Use ADLS Gen 2 for analytics. Implement the lifecycle management. Secure all the storage endpoint. Monitoring all the cost continuously. Okay. So, and what will be the let's take it from exam perspective. So it frequently tested scenario like if the organizations is need SMB based shared file storage, so answer will be your Azure file. Okay. And take the scenario 2, like the data scientists require petabytes scale analytics storage, so answer will be your Azure data lake storage Gen 2. And if we take the scenario 3, the companies store billions of the image and videos, so answer will be your Azure blob storage. And if we take a scenario 4, let's suppose a hybrid environment requires cloud backed file shares while retaining the local file server, so answer will be your Azure file sync. So now what we learned today? Okay, today we have completed one of the most important AZ-305 domain. Okay, like designing Azure storage solution, like as Azure,
Current
yeah,
solution needed. Yeah.
As Azure Solution Architect, storage design is a much more than selecting the storage services.
Mm.
We must balance the ability, durability, security, performance, scalability, cost, and compliance. So let's recap the everything we learned. Okay, first we learned about the Azure storage account architectures. We have started with the foundation of the Azure storage. We learned that the storage account act as a management boundary of the storage services. So a storage account can host the blob storage, file storage, queue storage, table storage, or data lake storage Gen 2. We also discussed the storage account types like general purpose V2, which is GPV2, recommended for the most workload because it supports the modern features, lifecycle management, blob storage, Azure files, data lakes storage Gen 2. Okay, we also look for the premium storage, which is used to which is when it is required, when the low latency needed, high IOPS, constant performance. So as a architect, our default recommendation is usually GPV2 unless performance required the
GPVs. Yeah.
dedicate otherwise. Okay, and we
Yeah.
also look the storage redundancy and replications. We then explore one of the most important architecture level topic like storage redundancy. We learned that redundancy protects
Mm-hmm.
against the disk failure, hardware failures, ability zone failures, regional disasters. Okay, we learn about the LRS, JRS, GRS, RAGRS, and GZRS. Okay, yeah. So
CRS.
most And so most importantly, we learned the high availability, which is not equal to disaster recovery. And this distinction appear frequently in both AZ-305 exam and real world architecture decisions. Okay, so that's bring us to end of the today's sessions. So today we covered one of the most
Mm.
largest and most important Azure architect domain. Like now you
Yeah.
understand the storage account replications model, blob storage, access tiers, lifecycle
Object
management,
storage,
Azure file sync, data lake storage gen 2. So these,
property
yeah, so
storage.
these concepts from foundations from designing this scalable, durable, secure, and cost optimized storage solution in Azure. So bef-
As well.
yeah, so before our next session, I encourage you have to review the LRS versus GRS versus GRS versus Z GZRS, blob
Yeah.
storage architectures, hot and cool architecture tiers, life cycle management, okay, Azure files, data lake Gen 2, and think about how this storage decision impact both the business continuity and the cost optimizations. Okay, so thank thank
Okay.
you for
Okay.
you the
Okay. Thank you
learning with
to
me
the
today. Okay, we will
thank
see you next session. Okay, bye bye.
you.